Hi guys. So today we're going to take a look at how do we determine if an inverse is actually a function. So kind of defining this term right here of our function. How do we tell if something is a function or not? And so we're really going to start out with an original f of x before we get to the inverse stuff and try to remember back to Algebra 1. How do we determine if f of x is actually a function or not? So it's either going to be a relation or a function. The way to determine if it actually fits the function criteria is if each individual x value that we would plug in has only one y value. So in other words, if I take something like, let's say 4 over here, and I plug that into my function, do I only get one y value? And so in this case, you can see if I plug 4 in, I get, we're just going to estimate here that that would be the point, 4, 1. Okay, when you plug 4 in, you get 1. There's no other values that you get when you plug 4 into this function because it doesn't hit the graph more than one time. So this is what we would call the vertical line test, because we can draw vertical lines and determine, are there any vertical lines that if I draw them, it hits more than one spot on the function. And in this case, I can draw as many vertical lines as I want. It only ever hits one spot, one y value that we would get. And so this first guy is going to be a function. Really, all lines are functions because you'll only ever have one y value to every x value that you input. That being said, if we look at the second function over here, the other red one, I'm looking for, are there any vertical lines that I could draw that would result in hitting two spots on my graph? And clearly, there's plenty of vertical lines I could draw. But let's say this was the same, like the x-coordinate of 4 here. This might be the point 4, -1. And this up here might be the coordinate 4. Let's just say it's up at 5. Okay, so clearly if I plug 4 in, I'm getting two different y values, or in other words, my vertical line is hitting two spots on my graph, and therefore this guy is not a function. All right, so the idea of being a function is if I plug a single x value in, that I only ever get a single y value out. And so we use our vertical line test for graphs. Now that being said, in this inverse section that we're in, you're going to be asked sometimes to take an original f, either relation or function. A relation would just be when it's not considered a function, if there's more y values for each x. And so this green graph here is our f of x function, or our f of x relation. In this case, it is a function because I could draw vertical lines and it would only ever hit one spot on my graph. But I'm being asked, is the inverse a function? So we got to think through, what do we know about inverses? Well, inverses flip the graph or reflect it over our y is equal to x line. So remember this diagonal line, y equals x, it would reflect it. I can stop right clicking. There we go. Over the line y is equal to x. So this green graph right now is kind of in a vertical direction. It would end up changing to a little bit more of a horizontal direction. So if I want to, without even graphing that f inverse function or relation, if I want to be able to tell if it's a function or not, instead of doing a vertical line test, since I know this is going to kind of flip and become more horizontal, I'm actually going to use what we would call the horizontal line test. So the horizontal line test helps you test the original graph to determine if the inverse is going to be a function or not. So in this case, can I draw any horizontal lines through my graph that are going to hit more than one spot on that graph? And of course here I've got a horizontal line that hits 3 separate spots. So that implies that my inverse is not going to be a function.